Hello. This video is for IXL Activity 8.N.2 titled Quadrants and Axes. This goes along with our review of the coordinate plane, quadrant plane. Coordinate plane has quadrants. The quadrant plane, I don't know if it has coordinates, but at any rate. So we're looking at the coordinated plane that has quadrants, and there are four of them. Remember that we start in the upper right corner here and we go counterclockwise. It is Quadrant 1, Quadrant 2, Quadrant 3, and Quadrant 4. Let's go ahead and kind of label those. I guess that'd be a good idea. So we have Quadrant 1, Quadrant 2, Quadrant 3, and Quadrant 4. One of the few times in life that we still use Roman numerals to label the quadrants of the coordinate plane. So which point is in Quadrant 4? We see that in this case it is point X. So X is the point in Quadrant 4. Going on, which quadrant is the point X in this time? So we have X down here. So remembering this is 1, this is 2, this is Quadrant 3, and this is Quadrant 4. And so we see that indeed point X is in Quadrant 3. Look at the coordinate plane. Which point is in Quadrant 3? So remember that we have 1, 2, oh, back, there we go, 2, getting ahead of myself, Quadrant 3, and Quadrant 4. So those are our quadrants starting in the upper right-hand corner and counting them going counterclockwise. Counter means opposite, so the opposite direction that a clock goes. So which point is in Quadrant 3? So I wasn't really looking. I realize now our answers are ordered pair. Remember, two numbers separated by a comma contained inside of parentheses. That is an ordered pair. We call them pair because there are two numbers. And we call them ordered because the X value comes before the Y value. The order does make a difference there. So we could actually plot these out, and we could go, let's see, the first point here. Let's label these. Let's pull it, get rid of that. Let's label these points A, B, C, and D. So 4, -5. So go over to 4 down to -5 would be right here. That is in Quadrant 4, and we're looking for Quadrant 3. 1, 2 would be over 1 up 2. So this would be Quadrant 1. And -2, -1, -2, -1 right here. Looks like we found our winner. This is in Quadrant 3. And why I wrote Arabic numbers here and Roman numerals there, I don't know. So it's going to be this one here. And -3, -5, or -3, +5, -3, +5. Point D would be up here in the second quadrant. Here, we'll use Roman numeral that time. Now, I could have done this a little bit easier. I didn't actually have to plot all of these because there is something interesting about the coordinate plane, and that is that we can tell what coordinate they are in by whether or not the X values and Y values are positive or whether they're negative. Now, you'll notice that here in Quadrant 1, anything up here is going to come from X values from the origin going to the right. And all the Y values are going to be from the origin going up. Remember, the origin is where the X and Y coordinate intersect. So to the right and up, everything here is going to be positive. So we're always going to have a positive X value and a positive Y value here in coordinate 1. Let's go ahead and look at not what I wanted. I want the eraser. Outstanding. And let's then go look at what about Quadrant 2? Well, if we go from the origin to the left, would have to be everything Quadrant 2. And we see that all those X values are negative, but still we're going up from it, right? Quadrant 2 is above the X-axis, so all of our Y values are going to be positive. So in that case, all my X values are going to be negative, and all my Y values will be positive. Now, looking at Quadrant 3, we see that Quadrant 3, to get an x value is going to be anywhere from the origin going left, so x will be negative. And to get quadrant 3, all those values, all the y values in quadrant 3 are going to be negative as well because they are below the x-axis, and all the y values below the x-axis are negative. Therefore, we would have a negative x value and a negative y value. And then finally, for quadrant 4, looking at that one, all of our x values would come from the right of the y-axis. So all these values here of x for quadrant 4 are going to be positive. And all of our y values, since it's below the x-axis, are going to be negative. So we know that all of our x values are going to be positive, and all of our y values are going to be negative. Now, with that piece of information, I wouldn't actually have to plot all of these points up here. I could just look for the one that matches the question. So which point is in quadrant 3? So quadrant 3, I know I'm looking for negative, negative. Positive, negative, positive, positive, negative, negative. Bam, there it is. What about this one here? Negative, positive, nope. So this first one here matches up with what quadrant 4 is. That would be in 4. Both these are positive, so that would be in 1. And this one here, negative and positive, negative, positive, that would be in quadrant 2. So you don't actually have to plot them. If you know this bit of information here of understanding when x is going to be positive or negative and when y is going to be positive or negative, you can then find the proper coordinate without even graphing. Let's look at the next one. Look at the coordinate plane, in which coordinate is negative 1, 3. So we have a negative and a positive. So if y is negative, it has to be from somewhere down here, right? Underneath, x. If x is going to be negative, then that means that it must be someplace to the left of the y-axis, right? Because over here all the x's are negative. And if the y is going to be positive, then we're talking about anything above the x-axis. So it would indeed be here in quadrant 2. So we'll find quadrant 2. And indeed, quadrant 2 is where all of our x values are negative and all of our y values are positive. Which point is in quadrant 1? Well, quadrant 1 we know is the positive quadrant, correct? So we're looking for two positives, and here it is, 0.34. Which point is in quadrant 4? Well, in quadrant 4 we know that x is positive and y is negative, correct? So we're looking for a positive, negative, and it looks like this one here, right? We have a positive, we have a negative, and does that match? Yep, positive, negative. Indeed, this is the one in quadrant 4. That would be 0.5, negative 5. Okay, so now we've gone to another concept of using inequality symbols, right? Less than and greater than. So we could also use less than and greater than to infer positive or negative numbers. So in this case, if x is less than 0, so that means that x is going to be, well, all numbers less than 0 are negative. And y is greater than 0. So all y values greater than 0 are positive. So where is the point xy? So x is negative, y is positive. So if we think about that, x is negative, so that means it's going to be to the left of the y-axis, and y is positive. It's going to be above the x-axis, so we're looking here at quadrant 2. And we found that out because we realized that x numbers less than 0 are negative, and y values greater than 0 are positive. On the next one, if the point xy is in quadrant 1, which of the following must be true? So in quadrant 1, right, we have positive, positive. So that means that x is going to be greater than 0, and y is going to be greater than 0, because any x number greater than 0 is positive, and any y number greater than 0 is positive. So let's find that in the answers. X greater than 0, y less than 0. Nope, that one doesn't work. X is less than 0. Nope, we're looking for x is greater than 0. X is greater than 0, y is greater than 0. Looks like that's the correct one. And here Nope, that won't work either because we have x is less than 0. So our correct answer is the third selection. If the point xy is in quadrant 4, so quadrant 4 over here is to the 4 is right here, right? And that means everything to the left, all the x's are going to be positive, and all of our y values, it's below the x-axis, so y value is going to be negative. So we are looking for a positive, negative situation. Let's see if that helps us any. And which of the following must be true? And they're using inequalities. So let's do the same. So if x is going to be positive, x has to be greater than 0. And if y is going to be negative, then that means that not x, but y. Then that means that y is going to be less than 0 for it to be negative. So x is positive, greater than 0, negative, less than 0. So let's find that. X is less than 0, not the right one. X is less than 0, no. See, I'm ruling it out because I'm looking for x is greater than 0, so I don't even have to look at this part here because I can already tell it's incorrect answer because the x portion is wrong. X is greater than 0, oh, we're on the trail there. That one checks out and that one checks out. And y is less than 0. Y is less than 0. Looks like this is the correct answer. And for the last one, this part would have been incorrect right there, correct? So that one doesn't work. The third selection is our correct answer. And I do believe that these are the last two. No, they're not. I got 4 more problems. So if x is equal to 0 and y is greater than 0, where is the point xy located? So let's go ahead and get our x-axis and y-axis here. Remember, this is our x, this is our y. Now, x is equal to 0. That means that, let's look at all the places where x is equal to 0. Get a blue one there, blue dot. So here, x is 0 right here. We go along the line, here's positive 1, here's negative 1. So right here is where x is equal to 0, right at the origin. Well, where else is x equal to 0? Here, here, here. It could be anywhere here. X could be equal to 0 at any point. And we know that y is greater than, or y is less than 0. So we know that y is less than 0. So y is a negative number. So that means that it must be somewhere in here, right? It would have to be anywhere on the y-axis and below the x-axis. So, but they're just asking us, is it on the x-axis or is it on the y-axis? So we see that it is indeed on the y-axis. And that happens anytime x is 0. The point is always going to be on the y-axis. Now let's look at the other question here. Create a xy axis there, want my coordinate plane. And now we're saying that x is less than 0 and y is equal to 0. Well, where is y equal to 0? Well, here y is positive 1, and here y is negative 1. That means right in between, right here, y is equal to 0. Well, where else is it equal to 0? It's equal to 0 anywhere along the, that's right, you guessed it, anywhere along the x-axis. So therefore, anytime that x is equal, or I'm sorry, not that, anytime that x is equal, or y, or I'm really getting confused, anytime that y is equal to 0, it's going to be on the x-axis. So in review, if x is equal to 0, it's on the y. If y is equal to 0, it's on the x. Kind of like backwards, you might say. And then finally, yes, indeed, these are my last 2 questions. If the point xy is on the y-axis, which of the following must be true? Well, that's kind of related to these questions here. So if it's on the y-axis, then x has to equal 0. All right, look at that again. There's my y-axis. Here's my x-axis. If I'm anywhere along the y-axis, here, 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 anywhere, right, y is going to equal 0 because x is going to equal 0 right along here. So with that said, let's go ahead and select x is equal to 0. And likewise, if the point xy is on the x-axis, which of the following must be true? So if we have our x and y axis there for our coordinate plane, and we're talking about the It's on the x-axis, so it's anywhere along here, right? -1 for y, +1 for y. The value of y is 0 all along the x-axis. So if it is on the x-axis, then indeed the value of y must be 0. Those are all of my examples for IXL Activity 8.N.2, Quadrants and Axis. Good luck with the activity.